Okay, welcome. So we're gonna end today with a very quick 30-minute kind of discussion about, no, it's gonna be short, about assumptions in cryptography and complexity theory. And I wanna, maybe I should introduce quickly. So Lee J. Chen, Antonetti, why don't you introduce yourself? Russell and Brian. Okay, so I introduced you. So the panel, welcome. The panel is about assumptions. And in particular, really we want to understand kind of how are we doing as a field, crypto and complexity, with regards to assumption? Are we too liberal? Are we too restrictive? Are there some assumptions that we consider good assumptions, not good assumptions? But I would really like you guys to take liberty and just say really what's on your mind. So in whatever order you guys choose. So it's a discussion.
All right. My view is that I think any assumption that can inspire research is good. Like, for example, strong exponential time hypothesis. I know Ryan doesn't believe in that. Maybe, I mean, that's at least what he thinks 10 years ago. I'm not sure about now. But I think SETS really inspire lots of research, so that's good. And also, I think concrete assumptions that are extremely strong are also good because it can inspire people to refute them. And so, yeah, that's my.
Well, I think assumptions and hypotheses are different, right?
Yeah.
Okay, I will get back to that.
We have to use the mic.
No,
Yeah.
okay. I'm talking.
Oh, you have to say something.
So yeah, actually, I like to maybe change the subject and and say so maybe the point is not so much the assumptions, it's the reductions. It's not, it's not you, it's me. It's the it really yeah, I know all of, with respect to what you were talking yesterday, all our results in crypto are unconditional because our results are always a reduction, right? And it's an unconditional result of what the reduction. And you can plug in assumption one side, you get another assumption on the other side, or you can uniform assumption, non-uniform assumption. You can also use it without any assumptions, or just reduced to human stupidity, like Phil Rogaway does, and it is still meaningful even if there is no hardness in a formal sense. So I think it's good to focus about reductions. And you said that assumptions are good if they foster new research. In some sense, assumptions are good if they help you come up with a good reduction. So that's maybe my point of view here.
I agree with all of the above. Obviously, it's hard to think of an assumption that is really bad, except unless it obfuscates completely the problem, in which case it's just not interesting. But I don't think that that there is anything that can be called a too liberal assumption. The false assumption is also good, of course, especially if you can show that it's false. I would say that probably we should try different types of assumptions that we should expand the type of assumption that we're making, not exactly type. This problem is hard, but somehow, not that I have any concrete ideas, but somehow make assumptions that, this process makes the problem harder or something of that nature.
Yeah, so clearly there are cultural differences between complexity theorists and cryptographers, and complexity theorists are probably very conservative with regard to making assumptions, and cryptographers are rather liberal. And I guess it's really a question of meeting in the middle.
Not so much anymore, right?
Not so much anymore. Yeah, we're trying to make them minimal now, I guess.
Here. Also in complexity theory, the number of assumptions.
Yeah. For example, what Ligia talked about yesterday, I mean, I think that's a good trend because we don't usually make assumptions that easily, but then when we make some new ones that leads to interesting research, you get unconditional results sometimes too from them. I mean, you might make a strong assumption, but you might get an unconditional result from it. But for me, I think an important aspect is also like assumptions which have from the cryptographic side, maybe assumptions that have implications not just for building crypto systems, but are relevant to foundational issues in other parts of computer science. And we saw in the talks today that IO is such an assumption, which is clearly relevant to issues across the range. And I think, yeah, to also value assumptions for having that rather than just their applications to cryptography is a good direction.
Okay, so I'm a big fan of Avi Wigderson's T-shirt that says, "Don't believe everything you think." Okay. So what I'd like to say is, you can make assumptions, but don't assume your assumptions. Okay. So, you mentioned the difference between an assumption and a hypothesis. So the exponential time hypothesis and strong exponential time hypothesis were carefully labeled hypotheses rather than conjectures, because I also don't believe them. I don't disbelieve them. I think they're interesting whether or not they're true or false. And so it's a question, not really a conjecture. Okay. And I think the best hypotheses or assumptions are those which are really interesting if they're true, but they're really interesting if they're false as well. Okay. So it's just a question we want to know the answer to, and it has a lot of implications if it's true, has a lot of implications if it's false. The danger is when we start talking as if our assumptions are always true. And this happens sometimes in fine-grained complexity, but I also see it happen when people are saying we give the first scheme with provable security, but that provable security is based on an ad hoc assumption that's only been in that paper. So okay, or in the random oracle model. Anyway, we've seen that results in the random oracle or other oracle models can lead to unconditional results later. That doesn't mean that they're not interesting. It just means that we shouldn't be selling them as if they're fact. Some constructions based on some new assumptions. There were a lot of famous papers being cited in the early papers in IO, in functional encryption, that were essentially, here's how we might do it, and then we'll just write down the assumptions that we need in this paper and hope that something like them is true eventually. And that's fine if you just want to establish that something conceivably might be possible, rather than you're claiming that it is the case. And so we should be just careful to distinguish between those implications, those reductions that are showing that something conceivably might be possible, and those assumptions mean that if this weren't the case, the whole landscape would change.
So people have touched on a lot of what I was thinking about saying. I guess for a long time, I've looked at or viewed hardness assumptions in a very operational way, sort of just challenges that when I think about them, they generate ideas. So I'm not trying to build secure crypto systems, and I think everyone is better off for that. So I'm just trying to get ideas. So often maybe I'm not even the true or falsity of a hardness assumption maybe is irrelevant to me. What is relevant is when I think about it. Does it provoke my thoughts in some new direction, or get me to think about things in a different way? And I think, Ligia briefly mentioned that I have a long talk where I speak about different attempts to refute strong ETH, Russell strong ETH and Mohan, Chris Calabros. Actually, I was trying to do that before it was even called strong ETH, as a grad student. And the reason why was that you're trying to find a CNF set algorithm and running in 1.9 in time. And so there's a lot of other problems that have slightly faster algorithms, but CNF SAT is just ever so different that, you know, somehow you've got to think differently. You've got to have a different approach to solving the problem than all the standard methods. And somehow trying to think about all these different attacks on it led to most of, I guess, what I published in what is now called fine grained complexity. So yeah, I think of them, I don't necessarily think of them as, you know, something I'm trying to build an edifice on, really is, but it is something that's like a muse almost, or like a thought provoker that is getting me to think in an interesting direction. But I will say, yeah, I mean, echoing a bit of what Russell mentioned about fine grained complexity, I've observed that, like, about hardness assumptions once they're like in a paper. So once they're published, I think like the general trend is often that people don't necessarily try to refute them. They try to say, oh, what can I build upon this new named topic, like this new named conjecture? Okay, what can I derive from it? Rather than, I mean, okay, maybe they're trying to derive false, but like, you know, instead of like trying to refute it, this seems to be like maybe the gut reaction or the most natural reaction to things. So in that way, you know, it can kind of narrow people's focus. On the other hand, if you do manage to refute this thing with a name, then you're guaranteed a paper. So like it does, like, you know, focus research in a particular way, but I feel like the default that people have is to just run with the assumption that's there instead of sort of treating it as like just food for thought, kind of, you know, could be true, could be false, not going to end the world one way or another, but like maybe, you know, it can get you to think about new ideas. Because I mean, yeah, for me, like new ideas are like the currency that whatever I'm always trying to get more of, like trying to understand. Yeah.
So I'm going to rip off Ryan. So maybe what we should do is, like, every time you make a new assumption, put a new assumption in the literature. Okay. You have to put a cash. You have to put up a cash prize for the person who refutes it. Yeah. And so the bigger your cash prize, you know, the more you're willing to bet on it, the more seriously people will take it.
Your website.
You against, because you would go broke.
I don't want them to be conservative, that's one thing. The other, I don't want them to obfuscate their assumption.
Okay.
I want the assumption to be as clear as possible.
But really, we work not for money, right? We work for the
glory.
world fame.
Yeah. I said, so I don't think it's such a great idea to have cash prizes. Because I want people to be liberal with their assumptions, and I want them to be as clear as possible so that it will be easy to refute. And cash prizes are go against both of these.
So I have a question for you guys. So you want to say something for a minute? Okay. I actually, based on, but wait, does anybody want to say something? Audience can, you know, interrupt.
Is there an example where the community went in the direction of following an assumption and it was a bad idea in hindsight?
Maybe knowledge assumptions.
Yeah, no one talked about knowledge.
Yeah.
But it didn't get so popular. Maybe it was before my time.
All the snark literature.
Yeah,
like,
it is very
successful.
successful.
Like if you've been to the zero knowledge yesterday from 5 to 9, it's all about knowledge assumptions.
Yeah, in the area, you know, it's in the water.
I thought you went to the game.
But he said if he wins.
You know what? Let me ask you a question about refuting. Forget, like, so Ryan, you said not enough people are working on, you know, refuting. Actually, I have to say, you know, you got a paper, man, I don't know, if someone comes up with an assumption that's, if the assumption is, like Russell said, if the assumption is interesting, if you refute factoring, yes. But if you refute an esoteric assumption, nobody cares. You just essentially found that the previous paper was less interesting. Why is it your job to spend your time on every Joe Schmo that comes up with an assumption to try to refute it? So I kind of, so I agree that on one hand, if the assumption kind of brings together some assumptions, like Raul mentioned, brings together or ties together different fields, or kind of shows, even if in the same field, kind of shows a little bit relationship between problems that we didn't know before via an assumption. And so in some sense, even if the assumption is not, we learn on the way, relation, even if the assumption then is broken, we won because we learned connections maybe. So I agree with the liberty of making assumptions, but I think hoping that people will spend time refuting them is over. I don't think they'll be compensated enough. And I'm not sure cash prize will, but I think that is an issue that we may have, even though I love new assumptions.
So I just want to say something about to guide with the knowledge assumption. I think it's a great example. It's really not an assumption. It's what it is. It's a reduction with the whole, right? We have a reduction, and there's one subroutine we don't know what to do, so we assume it exists, right? So it's really.
I disagree with you. It is an assumption. It's just a feasibility assumption. In complexity, we make feasibility assumptions. In crypto, we make infeasibility assumptions, but both are fine. Right.
But it's it's that this is the kind of like the quintessential non-falsifiable assumption. You can do it.
It's a different philosophy.
A little bit like assuming that IO exists. Great work today, but this is really a quintessential non-falsifiable assumption. But it's like assuming there exists IO, but go refute it, right? Okay, if there was an IO, then you can do it. No, it's not that this research is not interesting. It's very interesting to show the power of IO, but in a sense, it's not something that I would put as an assumption in the same line as other things. It's a whole notch which we like.
So I'd like to maybe ask you, what makes an assumption interesting? Because in all of this, like it's easy to come up with lots of assumptions, but when do we know we're making progress?
No one
At least to wait. So I have in my mind one benchmark, which is I met the complexity one. If the assumption is very, very simple and short, then it's a worthwhile thing to study. And that's it. I take a very postmodern view of these things. Just your size. If it's short, then it's fine to put it up there, and otherwise, I don't.
For instance, as Russell was saying, they thought that it's not a particularly useful thing for. And so I think everyone who read the paper didn't realize how interesting it is.
So I didn't hear.
IO, indistinguishability obfuscation.
Everybody but a couple people.
Yeah. No, but it took a while. It took a while. And I know from introducing, when telling people about it, they're sure that it's completely useless until I tell them how useful it is. So we don't know. It's like science. We just don't know.
That doesn't contradict Raphael's benchmark.
No.
Raphael's benchmark is easy to state.
Benchmark or do some other. How should we think?
Indistinguishable obfuscation is easy to state.
Yeah.
It's easy to state, so it's hard to argue. But then you just have to do something with it before it becomes very interesting. And once you do the first thing with it, that we didn't know what to do before, then it becomes very interesting.
Yeah, the historical status matters too, right? IO was already defined by Diffie and Hellman. I mean, the fact was this was considered independently interesting a long time ago. And in general, I think assumptions about problems that have been considered before are more interesting. I mean, if you define a new problem and then make an assumption about it, I mean, that's the kind of thing you might do to prove something very specific.
There are many holes, right? There are many historical coincidences that decide which problems are looked at, and we don't have a good coverage of.
It's not going to cover everything, but it gives maybe some more weight to an assumption if it's about a problem that's been considered before.
Simplicity is always with respect to some universal Turing machine, and it differs by a concept.
So only 5 meter right?
Yeah, and that really history depends on, the simplicity depends on the history, because what the concepts that are already fresh in your mind seem simpler than learning something new, no matter how actually kind of objectively simple it is. So so I have to like say, I'm not sure I'm a fan of the simplicity measure, because so something like a definition of zero knowledge or non-interactive zero knowledge has a number of quantifiers. It's longer than most of the things that appeared in the literature before. Something like security against adaptive chosen ciphertext attack. It takes a while to get right. So it's really like more the implications than I think the simplicity that matter.
But you don't know the implication until you study them.
Yeah.
Well,
Like, wouldn't it be if someone before having a construction of CCA secure encryption, if someone just assumed that something is CCA secure, that's a pretty bad assumption. Even that it's so complicated to kind of understand what it means.
well, what people assumed was it was impossible. So yes, just assuming that it was CCA secure. I mean, what I think what happened is people, yes, and correct me if I'm wrong, people were just like using intuitive notions of secure encryption and signature, and then different protocols that were built using these undefined assumptions got broken or were shown to have holes. And that's when people refined their reductions, refined their definitions, refined the assumptions that they built, that they used to build these things. So yeah, so like you know, encryption using braid groups is really simple if you're a braid group theorist.
Yeah, and we have this acronym method where everything is like at most 10 letters. It's very short. Okay, so we talked a lot about assumptions, and on the other side of assumptions, we have conclusions. And so actually in Rahul's talk, we heard about some conclusions like explicit constructions of combinatorial objects, natural combinatorial objects, some of which still do not follow from nice assumptions, even very strong assumptions that are not ad hoc or tailored to the actual primitive. We saw that the range avoidance problem, which could have been such a good assumption, does not quite work. So do you have any proposal for a very strong Uber assumption that implies basically everything we want, at least in the context of de-randomization related context and explicit constructions? Or do you have some other conclusions that you wish that they could be derived from? So basically a wish list for assumptions that serve specific conclusions, which we cannot still derive from anything nice.
Yeah, I mean, I think one example is assumption that you can generate and say time n to the 100, a string that's incompressible with respect to n to the 10 time algorithms. That's a very strong assumption, which implies all these explicit constructions. I mean, the congruent random string is itself an explicit construction for any reasonable notional explicit construction you want with polynomial time testability. And I don't think it's been like properly studied before. So I think that's, yeah, it's stronger than circular low bound assumptions. It's kind of a bit weaker than range avoidance, somewhere in between, and so we can still believe that it's true. So that's something I think.
I guess something maybe a little stronger than that is range avoidance, but for uniform like circuits, like which can be constructed from a polynomial time algorithm. But yeah, I don't really know whether to believe this is NP or not. But I mean, that will be like, that would still imply essentially all of the nice conclusions. So,
well, let me mention something like if you. Oh, okay.
Let me mention some assumption like if you have a sample distribution of range avoidance instances, then you have a deterministic heuristic with respect to this sampleable distribution. I think it seems still like a plausible assumption, although I don't know.
Actually, I think you can justify those assumptions in the random oracle model. So in the random oracle model, you can actually show range avoidance is not in FP, but for uniform adversary is actually NFP. You just pick a random string. I mean, I'm not sure whether that how interesting is that, but yeah, at least that can be kind of some evidence. Yeah. Oh, so can I say something more? Like, so we are talking about like for what type of conclusion and assumption. So one conclusion I want to see is to understand the optimality of randomization. So assuming something called NSETH is a very strong assumption. You can show every some t time randomized algorithm cannot be de-randomized with an overhead less than n. So a very interesting question is to find out some part of assumption to get the same conclusion, or actually to get better randomization. This is something like kind of fundamental because we really want to understand that to which degree you have to do generalization, and but it still seems to be very unexploited. Yeah, maybe you can use IO to show this, but I don't know.
Is it clear that you couldn't even show that unconditionally? Is it clear that you couldn't show that unconditionally with the n times t number? As far as I know, you might be able to do it using unconditional, right?
Well, unconditionally. I mean, you are proving some lower bound, right? Some problem cannot be de-randomized.
But you're saying there's something that you can solve in time t randomized t of n, which you cannot solve in time deterministic t time n.
Oh, I see. So if you can make t to be, I don't know, or one, then you can talk about finding majority b given a string with promise either it's 2 or 1. So we have to focus on t, which is super linear.
Yeah. But okay. It's not clear to me that you couldn't do this unconditionally.
Well, we don't.
Oh, you don't know how. What is that?
How about assumptions that people put up?
Oh no.
Yeah, ask ChatGPT to convert the Scott's Zoot into.
Yeah, I think instead of this being a complexity zoo of tamed creatures, this would be a complexity jungle.
Jurassic Park.
Yeah. But speaking of jungle, if I could just say one more thing about assumptions. I mean, I think like one aspect of assumptions which I quite like is when there are exotic assumptions that don't fit into the picture of the world we have easily. And I think IO is an example, as we saw, it doesn't fit into parts of those worlds easily. Or even like assumptions like keyless collision resistant hash functions.
A one-way permutation. Right?
Yes. Yeah. I mean, just to, it might not be clear how much you can do with these, but they sort of open up our kind of like imagination somehow in terms of how well we actually understand.
And just the final connecting Ligi's point about random oracles with the discussions about unconditional proofs, right? So we saw that in Hanlin's talk and in Alexis' talk, 2 examples of unconditional cryptographic results in generic models, right? NIZK in the random oracle model, or witness encryption using generic multilinear maps that have complexity theory applications. So even unconditional crypto, this is not about assumptions, but information theoretic crypto or generic model crypto has interesting consequences.
And another example is Hirahara's proof.
Yeah, secret sharing.
Yeah, secret sharing and
yes.
So you said conditionally against unbounded addresses.
Query bounded, yes, against query bounded.
Query bounded, but
yes.
conditionally.
They replace computational bound by query bound. Yeah. Okay, so I guess there is a lot more to say, and we can take further discussions offline. And let's thank all the panelists and.